Salyut 1 was the first space station of any kind, launched by the Soviet Union on April 19, 1971. More stations followed in the Salyut program. An heritage of that space station program is still in use on the ISS. Salyut 1 originated as a modification of the military Almaz space station program, then in development. After the landing of Apollo 11 on the Moon in July 1969, the Soviets began shifting the primary emphasis of the manned space program to orbiting space stations, with a possible lunar landing later in the 1970s if the N-1 booster became flight-worthy. One other motivation for the space station program was a desire to one-up the U.S. Skylab program then in development. The basic structure of Salyut 1 was adapted from the Almaz with a few modifications and would form the basis of all Soviet space stations through mere. Civilian Soviet space stations were internally referred to as DOST stations, although publicly, the Salyut name was used for all Almaz and DOST stations. Several military experiments were nonetheless carried on Salyut 1, including the OD-4 optical visual ranger, the Orion ultraviolet instrument for characterizing rocket exhaust plumes, and the highly classified Svanets radiometer. Construction of Salyut 1 began in early 1970, and after nearly a year, it was shipped to the Baikonur Cosmodrome. Some remaining assembly work had yet to be done, and this was completed at the Launch Center. Launch was planned for April 12, 1971 to coincide with the 10th anniversary of Yuri Gagarin's flight on Vostok 1, but technical problems delayed it until the 19th. The first crew launched later in the Soyuz 10 mission, but they ran into troubles while docking and were unable to enter the station. The Soyuz 10 mission was aborted and the crew returned safely to Earth. Its second crew launched in Soyuz 11 and remained on board for 23 days. This was the first time in the history of spaceflight that a space station had been manned, and a new record in time spent in space. This success was, however, overshadowed when the crew was killed during re-entry, as a pressure equalization valve in the Soyuz 11 re-entry capsule had opened prematurely, causing the crew to asphyxiate. After this accident, missions were suspended while the Soyuz spacecraft was redesigned. The station was intentionally destroyed by deorbiting it after 6 months in orbit, because it ran out of fuel before a redesigned Soyuz spacecraft could be launched to it. Structure. At launch, the announced purpose of Salyut was to test the elements of the systems of a space station and to conduct scientific research and experiments. The craft was described as being 20 meters in length, 4 meters in maximum diameter, and 99 cubic meters in interior space, with an on-orbit dry mass of 18,425 kilograms. Of its several compartments, 3 were pressurized, and 2 could be entered by the crew. Transfer compartment. The transfer compartment was equipped with the only docking port of Salyut 1, which allowed one Soyuz 7K OKS spacecraft to dock. It was the first use of the Soviet probe and drogue-type docking system that allowed internal crew transfer, a system that is in use today. The docking cone had a 2 meters front diameter and a 3 meters aft diameter. Main compartment. The second and main compartment was about 4 meters in diameter. Televised views showed enough space for 8 big chairs, several control panels, and 20 portholes. Auxiliary compartments. The third pressurized compartment contained the control and communications equipment, the power supply, the life support system, and other auxiliary equipment. The fourth and final unpressurized compartment was about 2 meters in diameter and contained the engine installations and associated control equipment. Salyut had buffer chemical batteries, reserve supplies of oxygen and water, and regeneration irradiation systems. Externally mounted were two double sets of solar cell panels that extended like wings from the smaller compartments at each end. The heat regulation systems, radiators, and orientation and control devices. Salyut 1 was modified from one of the Almaz airframes. The unpressurized service module was the modified service module of a Soyuz craft. Orion 1 Space Observatory. The astrophysical Orion 1 Space Observatory, designed by Grigor Gozadyanov by Urakan Observatory in Armenia, was installed in Salyut 1. Ultraviolet spectrograms of stars were obtained with the help of a mirror telescope of the Mersenne system and a spectrograph of the Wadsworth system using films sensitive to the far ultraviolet. The dispersion of the spectrograph was 32 A per millimeter, while the resolution of the spectrograms derived was about 5 A at 2600 A. Slitter spectrograms were obtained of the stars Vega and Beta Centauri between 2000 and 3800 A. The telescope was operated by crew member Viktor Patsayev, who became the first man to operate a telescope outside the Earth's atmosphere. Specifications: length 15.8 meters. Maximum diameter 4.15 meters. Habitable volume 90 cubic meters. Mass at launch 18,900 kilogram. Launch vehicle, Proton. Span across solar arrays, about 10 meters. Area of solar arrays, 28 square meters. Number of solar arrays, 4. Resupply carriers, Salyut 1 type Soyuz. Number of docking ports, 1. Total manned missions, 2. Total long-duration manned missions, 1. Visiting spacecraft and crews. Soyuz 10, after taking 24 hours for rendezvous and approach, Soyuz 10 soft-docked with Salyut on April 23 and remained for 5.5 h. Hard docking was unsuccessful due to an unforeseen design flaw in the Soyuz's autopilot. A crew could not enter the station and had to abort the mission. Soyuz 11 required 3h19 minutes on June 7 to complete docking. A crew transferred to Salyut and the mission was announced as checking the design units, onboard systems, and equipment of the orbital piloted station, testing the station's manual and autonomous procedures for orientation and navigation, as well as the control systems for maneuvering the space complex in orbit, studying Earth's surface geology, geography, meteorology, and snow and ice cover, studying physical characteristics, processes, and phenomena in the atmosphere and outer space in various regions of the electromagnetic spectrum, and conducting medico-biological studies to determine the feasibility of having cosmonauts in the station perform various tasks, and studying the influence of spaceflight on the human organism. On June 29, after 23 days and flying 362 orbits, the mission was cut short due to problems aboard the station, including an electrical fire. A crew transferred back to Soyuz 11 and re-entered the Earth's atmosphere. The capsule parachuted to a soft landing in Kazakhstan, but the recovery team opened the hatch to find all 3 crew members dead in their couches. An inquest found that a pressure relief valve had malfunctioned during re-entry, leading to a loss of cabin atmosphere. Pressure suits had not been used on Soviet manned spacecraft since the Vostok program. Re-entry. Salyut 1 was moved to a higher orbit in July-August 1971 to ensure that it would not be destroyed prematurely through orbital decay. In the meantime, Soyuz capsules were being substantially redesigned to allow pressure suits to be worn during launch, docking maneuvers, and re-entry. The Soyuz redesign effort took too long, however, and by September, Salyut 1 was running low on attitude control gas. It was decided to conclude the station's mission, and on October 11, the main engines were fired for a deorbit maneuver. After 175 days, the world's first space station burned up over the Pacific Ocean. Pravda reported that 75% of Salyut 1's studies were carried out by optical means and 20% by radiotechnical means, while the remainder involved magnetometrical, gravitational, or other measurements. Synoptic readings were taken in both the visible and invisible parts of the electromagnetic spectrum.